Hi, welcome to Vision System Training Session 1. In this training session, we will cover VBAI-based vision system briefly. The topics we are going to talk today are listed here. We will start from the software, which is VBAI. VBAI stands for Vision Builder for Automated Inspection. And then we will take a look at the components of VBAI system and the communication flow between vision system and the robot. We will then look into the structure of our vision programs and the basic tools used in the programs. Then we'll take a look at how to run VBAI-based vision programs. After that, we're looking into three things. One is the camera exposure, and the second is the locating methods, and the third is the measurement methods. And then finally, we will look into briefly about the procedures of troubleshooting in VBAI programs. Okay, first of all, let's take a look at the VBAI software, which is developed by National Instruments. There is a tutorial file of the software available online. Also, the tutorial and the manual files are available from any computer that is installed with VBAI software. You can find the files in this folder. So if we open the folder, we will see two PDF files. One is the manual file and the other one is the tutorial file. The tutorial is really a very useful one and quick to go through, easy to go through. So there is a simple introduction of the software and also the common tools, most common tools, and it also contains more than 10 simple samples that are feasible to go through. Also, those files can be opened from computer menu if you go to the program menu and follow these directions. The software itself has two interfaces. One is the configure interface, which can be accessed from by clicking on this tab. This is used for programming purpose. And the other interface is the inspection interface, which can be accessed by clicking on this tab. It is for running inspection. Now, let's try to use this software to create a very simple inspection program. Assume we have two image files. One is a good part showing completed features here. The other image file shows a bad part with a short portion here. We can follow the steps listed here to create a program. First of all, let's use the configuration interface. The next step, we will use simulation acquisition tool. We'll open an image file. Let's pick up the good image. Uncheck the cycle through for the image option. Now let's use the match pattern tool to create a pattern. After clicking on the tool, you can immediately see a template creation window pops up. So let's define the pattern template. Typically, the pattern template covers the interested feature. Let's click on OK. Let's adjust the window size properly. You can also see, actually the red zone in which the pattern template has been defined. You can also see a green zone, which is actually the pattern search region. So we can adjust this region properly. Now, if we take a quick look at each tab, this template tab is the one allows you to create the template. Now you can see this red spot here. This is the origin of the template. You can adjust the location of this origin to a place that it can be easier to be recognized. It can also be adjusted through the offset values. The next tab is the settings tab, in which you can define the minimum pattern score. The default value is 800, which is a pretty high, good score. The maximum value is 1000. In the inspections, we can use 800 or 700, 600, or 500, depending on how tough the difference can be. And in this portion here, you can check out this portion to allow certain rotation of the pattern. Typically, you can place at 5 degrees if the rotation is not too much, plus minus 5 degrees. And in the next tab, you can define the pass and the fail. You can define the pass and the fail criteria. So this is step number 4, define the pass and the fail criteria. So here you can define the inspection will be passed if the matched quantity is 1 or more. So the minimum number of matches is 1. And then click on OK. And now this pattern is defined, but the pass or fail status won't be reflected in this inspection status here. In order to let this inspection status being showing up here, we will follow step number 5. Use the set inspection status tool. So we'll pick up this tool here. Now the default setting is the status will be failed if any of the previous steps fails. Let's check OK. And then if you run through once, you can see everything is passed because this is a good part. Now, if you pick up the image of the bad part, and then if you run through again, you will see the pattern match fails, and also the inspection status fails here. Okay. Now, that was step number 6, test in the configuration space. Now let's save the program. Actually, before saving the program, we'll check out the cycle through option. So in this way, all the image files will be gone through by the Vision program one by one. Okay, let's click on OK, and then save it. Save the program. We'll give it a new name, simple inspection. Save it. And then we will, the next step, right? switch to inspection interface. Switch to inspection interface. All right, adjust the size property. And now run the inspection continuously. So what you are seeing is that the vision program is going through the two pictures. One is good, the other is bad, continuously cycling through. And you can see a counting of pass and fail here. Okay. And also it shows the yield percentage over here. That's all for this simple program. There are two interfaces in the VBAI software. The first interface is called the configuration interface, which is for programming. Its layout is composed of 4 areas. The main window area, the overview window area, the inspection steps palette area, and the state configuration window area. In the main window area, we can see the current active image. In the overview window area, we can see the flowchart of the vision program. In this inspection steps palette, we can see all the vision tools, and we can select the vision tools to be applied in the vision program from here. In this state configuration window, we can see the tools being used in the current inspection in the current vision program. Now, take a look at this tool. This is called the toggle tool. If we click on this toggle tool, we can see the contents between the main window and the overview window swaps each other. Now, if we highlight a bubble, actually we shouldn't call this bubble. We should call this state, which is a formal name. So if we highlight a state, the tools involved in that state is displayed in this state configuration window. Now, also let's take a look at some frequently used icons. This is the open file icon, and this is save file icon. And here are 3 icons to adjust the size of the window. Okay, and this is the icon to execute to run the vision inspection once, and this is the icon to run vision inspection in loop. And this is to run the inspection until it has a failure. And here is the tool here is a stop to stop the currently running program. Now we also have in each state we have the tools available. We have the icons available here. This is the icon to run the once. To run the state once, and here's the icon to run the state continuously. So let's select a state and take a look. Okay, 1176, this one. Okay, and let's take a look. If we run this state once, to see what happens. Okay, you can see, let's see. So you can see the results like finding. Okay, you can see the coordinate system established and some patterns being found. Okay, so if we run this continuously, if we click on this loop, and then it will run continuously. Then if we have a lot of files in the folder, then it can loop automatically to every file repeatedly. And if now click on this, it can stop the loop. Okay. The second interface in the VBAI software is the inspection interface, which is for running a vision program. Its layout is composed of 4 areas: the main window, the overview window, in which the pass and fail the quantities, and also the yield rate are displayed. Here is the area showing the active and idle time. And this is the window to show the results of each steps. To access the inspection interface, you can click on the Inspect Product tab. And then you can open the inspection, you can open the vision program. Adjust the window size. And then we can click on this Start Inspection button. And now you can see the program is looping. And you can see the results of each step here. Since we have a good part and a bad part in the folder, and so the results of the good and the pass and the fail are alternating. Here is some more detailed information of the inspection interface. Alright, showing here is the mode number, and this is the picture ID number. For instance, this is picture number 2. And also here shows the shift passed quantity and the failed quantity. So if the current picture is passed, there is a pass result here. Otherwise, you will see a red failed result. This window here is the target window for the inspected feature. So sometime when the feature is out of the target frame, it may cause some rejections as well. So please pay some attention to this window. This is the block diagram showing the components of our VBAI-based vision system. It has a personal computer, 1 or more cameras and lenses, the illumination. Inside the computer, there is a FireWire card and an input-output card. There is also a driver software for the input-output card. So between the personal computer and the cameras are the FireWire cables, and there is a cable to the terminal block, which is connected to the LED lights and the Lobot. Such a vision system is classified as a PC-based vision system. The other type of vision system is smart camera-based vision system, such as Cognex vision system. Now let's take a look at the communication flow between the VBAI-based vision system and the Lobot. The Lobot output signal is typically a 4-bit signal. With the 4 bits, it can output unique combination for each mode or each job. It can also output a unique reset signal, which is all 0, or the camera trigger signal, which is 0001. For the vision system, and the output signals contain a pass-fail signal and a vision completed signal. So at the beginning of each cycle, the vision system resets and outputs its initial status, which is all low, for pass-fail signal and completed signal. For the robot, at the beginning of each cycle, it will first check the status of the vision system. It is called the interlock check for vision system. So between the robot and the vision system, the robot is always a master, and the vision system is typically in an awaiting status. So waiting for the job signal from the vision from the robot, and also waiting for the camera checker signal from the robot. And then once all the pictures are completed, the vision system will output the pass-fail signal and the vision completed signal, and then with this signal from the vision system, the robot will dispose of the parts. Showing here is the structure of VBAI-based vision programs. This is actually a program running at station 16. At each cycle, it starts from here and then end at here. So here is the state that the vision program is waiting for job signal from the robot. Once it receives the job signal, it will turn on the LED light and then calculate the job ID based on the 4-bit signal received from the robot. Then it will assign camera exposures based on the job, and then the vision system will be waiting for camera trigger signal from the robot. And once received the triggering signal, it will take an image, and then this portion is for locating and inspection. Like for instance, this is for job 11 mode 1175, picture number 1, and here is also 1175, picture number 2, and here is for another mode, another job. Okay, and after that, once the inspection is completed, then it will output the pass-fail signal and also vision completed signal here. And then it will turn off the LED light and then wait typically for 3 seconds to keep the output signal and then end the cycle. Let's take a look at the tools being used in the vision program. Here is the locating and inspection portion of a vision program. This is for picture number 1 of mode 1176. Let's highlight this state, and now it shows the steps of this state here. If we click on this icon once, then we can add a tool after that. Let's add an simulator acquisition tool after that to open an original image file. Adjust the size, and then if we click on a tool, and then if we double click on the tool, you will see the parameters setting tabs over here. However, you may not quite understand what those parameters mean. Then there is a help menu available. So if you click on this menu, help, and show context help, and then it will show the context related help here immediately. So you can take a look at those notes So to understand the parameters involved in the tool. Now this is the locating state. Let's try to let the run through the locating state by either by clicking on this step through once, or just pull the bar to the end, click on the final tool, and then it just runs through immediately. And then after that, we can go to the next state. This is the inspection state. And then if we pull the bar to the end, click on the final tool, it actually runs through this state. And then if we want to understand the parameter setting over in this inspection, and we can just double click on the tool and look at each parameters, the settings. And then if you want to understand more on this tool, you can again click on help and show contacts help. It will show the relevant tips of this tool. And we have dozens of tools that need to understand. So here's a list of the basic tools used in the vision programs. I hope you may look into each tool and understand how to use them. And you can also look into the programs and see how the parameters are set up. And then if you have any question, please do not hesitate to ask me anytime, or send me an email, or just make an appointment just to see me, or just come to see me anytime if I'm available. Okay.